Hi everyone, this is the first of my videos on AI, and I'm particularly interested in AIs which can be used in a broad problem-solving context, not just AIs which are narrow in scope like optical character recognition or driverless vehicle technologies, but things which can be used on a broad problem-solving front in a big project. And the best tools probably that we have for this type of application at the moment are the chatbots, things like ChatGPT, Copilot, and Gemini. And I really want to see how these tools can help augment a user in a project and help them to get to superior project outcomes more quickly. So what I did is I subscribed to ChatGPT and I undertook a few little experiments to find out. There are a couple of things that I discovered pretty quickly. The first was that yes, ChatGPT helps me to come up with answers much faster than before, and the answers are well structured, well presented, and quite comprehensive. Problem is that these answers are not always correct, which brings me to the second point. And the second point is that the outcomes that people are going to achieve by working with AIs and projects are still going to be very dependent on the human user, on their knowledge, their critical thinking ability, and their energy. We might all be using similar AI tools which are built on similar algorithms and populated with similar big data sets, but the outcomes of the projects are going to depend very much on the human collaborator for their ultimate productivity. As an example, consider if everybody had access to a general AI like Tony Stark's Jarvis in the Avengers movie. Now, if you're Tony Stark, you're going to be able to use Jarvis to build Iron Man suits. But if you're somebody else who knows nothing about that kind of technology, maybe you'll be using Jarvis just to download your favorite movie and to switch on the kettle. So the outcome depends hugely on the user. The other thing, or the other reason why the outcome is so dependent on the user is because we all come from very different backgrounds and we all have very different circumstances and data sets which are specific to the particular purpose which we're using that AI for. And we need to be able to tailor the AI to use that specific data set and to work within the circumstances that are particular to us. Let's have a look at an Excel example to understand what I mean a bit better. Here we have a very simple data table of just 5 data points, where the X values are the Apple unit prices in pence, and the Y values are the volumes of apples sold at a particular unit price. We also have the data shown in the form of a scatter plot. And as a human, I can immediately see that there's a trend at work, where as the Apple unit prices reduce, the volume of apples sold increase. Now, that kind of relationship establishment is something that machines couldn't do until recently. It's only recently that we've equipped machines with the ability to actively go about looking for relationships or ways to establish relationships between different data sets. And that's something which is key to AI, and it applies not just to numeric examples like this, but also to non-numeric examples. And I'll talk further about this in a different video. Now we can see how this might work if we right click on a particular data point in the curve and we choose to add a trend line. What we're provided with is different algorithms to use to try and establish a relationship between the X data set and the Y data set. Currently the algorithm which is being used is the linear regression method, which means that the machine is going to use a straight line, a best fit straight line, as a proxy for developing an equation between the X value and the Y value. We can show the equation by clicking on the functionality on the menu, and there we have our trend line with the equation. Now there are a few things we can learn from looking at this data. The first is that over here we have, for a single unit price, we have multiple Y values. Now this might be the volume of apples sold at that unit price in month 1, this might be the volume of apples sold at that price in month 5. But the machine's using a purely sort of statistical method where there might be a distribution of Y values about the trend line, but the machine isn't looking at any more detailed or complicated logic to try and figure out what those Y values might be. As humans with access to more data, we might, for example, know that the sales in any particular month at any particular unit price are due to customers having provided us with their order sheets where they've said at a particular month and at particular unit prices, this is how many apples they're going to buy. So we would be able to use that information in a deterministic model to calculate the Y values or Apple sales volumes with a lot greater precision than if we relied purely on a statistical forecast which was provided by an AI, right? So that's something to note. The other thing is that there are only 5 data points in this data set, and what that means is that this trend line developed by the AI is quite variable. It will change quite dramatically depending on a material change of a single data point. So the curve slope is currently 86 and intercept is 4189. If I was to change the Y value there from 1552 to 2000, you can see that the slope now changes by quite a lot from 86 to 62, so that's 24 data points, and the y-intercept changes by about 460 data points, right? So that's quite a substantial change. If we had more data points, the trend line is more accommodating of a change in a single y value. It won't differ by that much, and we can see that on this tab here where we now have 30 data points, and the curve here has a slope of 82 and the intercept is 4169. If I was to go to the same y data point and again change it from 1552 to 2000, we see that the slope only changes by about 4 and the intercept changes by about 70. So we can have a lot more confidence that the trend line has settled about a particular sort of set of variables. So that's the next thing to note. Finally, let's talk about what a single data point might be. It might be the composite value or an aggregate of unit sales to multiple different customers, right? Now, if I am a particular customer, then my sales curve will be different to that of the overall market, right? And it's not just a proportionate reduction based on my fraction of the market. It might be that the slope changes, to be a completely different gradient and going in a completely different direction. I'll give an example, right? Currently, here we have customer D. The slope looks similar to that of the market, but customer D's sales volumes are going to be lower, so it's a lower slope with a correspondingly lower y-intercept, but roughly proportionate. However, if I was to look at customer B, we can see that both the slope and the y-intercept have changed dramatically. Now the slope is just 1, right? So it changed from a negative slope to a positive slope, and the y-intercept is much smaller. So if I'm customer B or A or C or D, it makes far more sense for me to be trying to figure out the trend particular to me and not relying on a proportionate adjustment of a market-wide trend line provided by the AI. So to sum up, firstly, yes, working with AIs can benefit productivity hugely, but the results that you get will depend very much on the skills and ingenuity of the humans who are collaborating with the AI. What you get out will be very much proportionate to what you can put in. Secondly, AIs have been built on large data sets, and these data sets may vary from AI to AI. So that means the results may also vary from AI to AI. And I'll demonstrate this with a non-numeric example in a later video. Finally, customers or people and companies who can use their own data sets and who can model the relationships that are specific to their own businesses will be able to come up with more precise and more useful results and forecasts than if they rely purely on broad brush AI data. I hope that's been useful, and I look forward to speaking to you again in a later video.